In this video, we're going to talk about solving inequalities. Before we take a look at a few examples, let's talk about the notation and the visuals and the vocabulary that you're going to need to know in order to discuss and understand how to solve for inequalities. So the thing all the way to the left here under picture is something that you've probably seen before. So when you graph on a number line where you have an open circle, closed circle, when you shade in between or outside of, that is a visual. That's a graphical picture of how to solve an inequality. Keep in mind, an inequality has a range of solutions, where an equation has one or two or however many distinct answers. An inequality is going to have multiple. Now, the largest range you are going to have is all real numbers, which means everything works. But normally you have some kind of restriction. So with your open circle, remember it doesn't include that number. If it's closed, it includes it. So when we talk about that, whether it's an interval or set builder notation, which we've touched on before, you can write it in two different ways. All three of these things mean the same exact thing. It's just represented in different ways. So if you have something here, these would be your open circles. We use parentheses to denote that. So if it has 2 on the end, so 2 open circles, it's going to have 2 parentheses around it. And we would say x is an element of, so it would include A to B, but it wouldn't include it because remember those would have the little lines underneath it, which means less than or equal to. So if we had a situation where it would have closed circles, so these would be closed, we use brackets to denote that, and that would have an equal sign underneath there. You can have a combination of either of those. You could have closed circle, open circle would look like this, or you could have open circle, closed circle, and it would look like that. Something else to denote down here is that infinity, so if it goes to infinity or negative infinity in whichever direction you're pointing in, that will always have a parenthesis and not a bracket, because remember, infinity is not a number, it's not something tangible, it's just an idea or a concept. All right, let's get right to solving these things. So I'm going to solve for x. I'm going to treat this just like I would an equation. I'm going to move my 2x over and my 7 over here. And what I solve for is x is greater than or equal to negative 5. And when I graph that, I'm going to put a closed circle on negative 5, and I would shade to the right, including shading that arrow because it goes on to positive infinity. Now, if I was going to use interval notation here, I would put a bracket around negative 5 because it includes it, and then it goes to positive infinity, and that's going to put a parenthesis around that. And then if I'm going to use set builder, the thing with the curly brackets, I'm going to define x. X is an element of all real numbers, and x is greater than or equal to negative 5. So for this example, I'm going to solve it in the same way as I did the last one, except instead of applying whatever operation to 2 sides, I have to do it to 3. So I'll work through that. So what I've done is I've isolated x, but something that happened right before I got to that point was that I had to divide by a negative, and when you do that, remember, you have to switch your signs. So you could write it this way, or you could swap the numbers around in the signs, and you get this guy, depending on what you're more familiar with. And let's graph it. So I'm going to have a closed circle on negative 3, and also a closed circle on positive 1. So I know that if I'm going to shade, it's going to be x is going to be greater than this guy, and it's also going to be less than this guy, so that means that I shade in between. And in interval, that means that it's going to go from negative 3 to positive 1. It's going to be brackets because it includes those things. And then set builder, x is an element of all real numbers. Then I just repeat this guy. That's it. So we can't talk about solving inequalities without also talking about absolute value. So here we have the absolute value of the quantity 2x plus 4, and that's less than or equal to 3. So I have to consider 2 cases here, and that is my positive case, so that's 2x plus 4 is less than or equal to 3. Nothing really changes. And then I have to also consider 2x plus 4 and a -3. And so that's also going to change this sign here. And I'm going to solve it like I did the last two. Now I get my two solutions for x. Let's graph it. So my -1/2 is about right here, and that's going to be a closed circle. And my -7/2 is -3.5, so that's going to be another closed circle here. Now if I'm curious as to where to shade, if I'm talking about the purple one or the first one, its x is less than that, so it goes in this direction. And then if I'm worried about the red one, or if I'm curious, I'm going to shade where x is greater than, so it's going to be this way. So we shade towards each other. So when I write my interval, it's going to go from -7/2 to -1/2 inclusive, and then set builder, x is an element of all real numbers, and we can include this in one inequality, so -7/2 is less than or equal to x, which is less than or equal to -1/2. Fit in that curly Q in there. All right, one last example. So remember I have my positive case and my negative case, which switches the sign and the inequality symbol. So I'm going to solve for x. So I have x greater than 4 or x is less than 1. Let's graph it. So open circle on 4, open circle on 1. X is greater than 4, so I'm going to shade this way. X is less than 1, so I'm going to shade that way. Shading this way, including the arrows. So this one's different because the arrows point away from each other. So the way that I write my interval here is I'm going to need a union of two things. So the way that I would write that is -infinity is going to go to +1. Remember, it's not going to include that open circle. So the union, so I start over here with the 4, and that goes to +infinity. So that's how I would write that there. Now if I wanted set builder, x is an element of all real numbers, then I would just write these guys as I see it. So I would say x is greater than 4 or x is less than 1. And it is for real that this video is over. Get it? For real? Alright, I'm going to go now.